My name is Hakan Alpan. I am from Çukurova University, Turkey. I am also a member of Landscape Research Society, which is an NGO acting in the field of landscape research and aiming to increase public awareness about landscape research and all kinds of research related to landscapes. Before I start, I would like to express my feelings about the hats-on session. Well, I think I was the only person who doesn't have a hat, but it wasn't deliberate. I tried to find anything like a hat in my office, but I couldn't find. Please accept my apologies for that. Also, I am very delighted by the presentations, especially the presentation from Francisca, because I was in Norway in 2007 and I lived for a short while in Trondheim. And when I was there, I was always asking the same question, why it is so difficult to get to the waterfront of the historical city. And now I am very happy to hear that there is a promenade now and accessing the waterfront is much easier. Actually, I will be talking about a project that we as Landscape Research Society conducted in cooperation with Izmir Metropolitan Municipality. And the aim of the project was to develop a framework to make the cities, coastal cities, more resilient to climate change. Before going into details about the project, I would like to express a few things to make a basis for why we developed this project. As you know, landscape systems are subject to change. We, as landscape architects, experts, and landscape professionals, we know it very well. And it has direct and indirect impacts on human and communities. We also are very well aware of that. As Harris mentioned in his presentation, there are two approaches to deal with direct and indirect impacts on human as far as landscape transformation or change of the landscape systems are concerned. In the traditional approach, communities generally act as usual without changing their attitudes towards environmental issues, because there is an easier way to tackle the problems. You can develop engineering solutions as problems arise. But I will show you a picture. If we take a broader view, this becomes very complicated. For example, if you think in terms of a traditional approach, you can let carbon emissions increase because at the end you can find an engineering solution. For example, in this case, if sea level rise is a problem, then you may try to find an engineering problem. So what do you think about the engineering problem? Could you think that building a dam around a sea ice, polar sea ice, could be a problem? Of course it couldn't be. It's nonsense. So we have to change the paradigm, and the basis for the project was about to change the paradigm. So what should be the paradigm? First of all, we can develop scientific solutions and use engineering and technology. It's okay. I mean, it's necessary. But also we need to develop policies, strategies, methods, and tools to adapt to the changing conditions. Then we can make plans and we can then implement. And in order to understand what's going on, our implementation, we need to monitor. This is a cycle that we can describe for adapting, for making the cities or communities resilient to climate change. First of all, we need increased awareness about the problems. Then, as I mentioned, we use science and technology where we can apply it. We can also develop policies, strategies, methods, and tools for adaptation. Then we implement and monitor. In this cycle, we focused on the policies, strategies, methods, and tools for adaptation. And for this reason, we tried to derive different information layers, geospatial information layers. And then we try to combine all this information to come out with a solution to make cities more resilient to climate change. So in this scheme, we had climate models, land cover and land cover change models. We also produced green infrastructure maps. We also mapped ecosystem services, and we provided recommendations in the light of the information we derived from these applications, and also from good practices from all around the world. So this is a chart for how we integrated the spatial information. In order to adapt climate change and climate change related issues, we need to know what the land cover is and how it changes. And then we may produce future projections, and we may use these future projections to develop climate change adaptation strategies. And at the same time, if you know about climate change scenarios, then we will have much stronger basis to produce adaptation strategies. And of course, we need green infrastructure, information on green infrastructure and spatial characteristics of this infrastructure, because it's also important, and it is also delicate, and it can be affected by climate change. So what we did in the project, we developed climate change models, and we used several variables like monthly, seasonal, and annual average temperature, and many other variables for the city of Izmir, for the whole city. And when we derived these models, we used downscaling approaches. I don't want to go into the details about this methodology. And after that, we produced land cover information for the part of the area. Actually, this is a central, one of the central districts of the city of Izmir, and we employed other analysis for one of the central districts of Izmir, Balçova. And we produced land cover change information. This was also important for us because we used this information to develop future projections for the city, for the central district, and for the city of Izmir. Here are the maps for the projected land cover for 2050. To the left-hand side are the projected land cover under two scenarios, scenario 1 and 2. One scenario is current uses current land use trends, and the other scenario was a loser scenario. I mean, protection measures were not taken into consideration. To the right-hand side are the urban development scenarios for 2050 under two different scenarios. We also mapped green infrastructure. Here are the 14 classes of green infrastructure for the central district of Balçova of Izmir. And we needed to understand the composition and configuration of the green infrastructure system in order to come up with solutions about resilient city. And we calculated several indices like percentage of landscape, perimeter, area ratio, etc. And then we defined strengths and weaknesses of the green infrastructure system of the study area. Just few slides. I don't want to make it any. Any questions?
Can you come to an end, please?
Okay, thank you. And we also mapped ecosystem services by calculating and mapping stormwater runoff capacity, carbon dioxide sequestration, etc. And we came up with recommendations based on the change of the temperature and rain, recommendations for land use planning, for management of urban green areas, for stormwater management, etc. And we classified our recommendations as, for example, project level recommendations, and we described what kind of projects should be employed to make the city more resilient. And also we classified our proposals as strategy level proposals, proposals for implementation techniques, action level proposals, etc. Thank you for listening, and I would like to finish with the picture of beautiful city. If you are interested, you can find more information by clicking the link below. Thank you very much.